Hey guys, let's discuss new problem from dynamic programming series. So the first problem is Fibonacci number. Okay, so let me explain that we will be covering 8 to 10 important patterns in dynamic programming, and the first pattern is 1D array. So we will be solving 4 to 5 questions in this pattern. Okay, so first problem is Fibonacci number. So do you know what is Fibonacci series? Let's say if the number is 0 and 1. Okay, so if you do summation of these two numbers, 0 plus 1 will come. So the next number in your series will be 1. Okay, now take last two number and get a summation of those two numbers. 1 plus 1 2, so 2 will come in a series. Okay, now 1 plus 3, so 3 will come. 3 plus 2, 5 will come. And if we are starting from 0, indexing, okay, 0 1 2 3 4 5, and if someone will ask you what is the n equal to 5, fifth number of the series, so you should answer 5, right? Fifth number of the series if the indexing is starting from 0. So how you can find that? If you go with recursion, you have seen the recursion solution for this. Okay, and recursion solution is very simple. So this is the recursion solution, okay, where you find the Fibonacci of int n equal to 5, and then here if n is less than equal to 0, then you return n. Okay, means less than equal to 1. So it means if n is 0, the answer will be n, means 0. If n is 1, then answer will be 1. Okay, otherwise you will find fib n minus 1 plus fib n minus 2. This is correct, right? If you have number x, y, z, then how you are calculating this z? You're finding x plus y, summation of last two number, right? If this is f of n, then this one will be f of n minus 1, and this one will be f of n minus 2. So you're finding the summation of that, correct? And you have a base condition. If n equal to 0, return 0. If n equal to 1, return 1. So let me dry run this, okay, from recursion side. So if I wanted to find fib phi, how I can do? See, n is equal to 5. Okay, 5 is less than equal to 1, condition false. So what it will return me? It will return fib 4 plus fib 3. Okay, so now this function will run for fib 4. So what will be the answer? It will return me fib 3 plus fib 2. Okay, now this one will run for fib 3. So what it will return me? It will return me fib 2 plus fib 1. Now you know that if n is equal to 1, it will return you 1. So here 1 will come. Now what will be the answer for fib 2? So for fib 2, okay, again let's check. So it will be returning you fib 1 plus fib 0. Okay, now you know if n is 1, then it will return you 1. If n is 0, it will return you 0. So fib 2 will return me 1 plus 0, which is 1. Now fib 3 will return me 1 plus 1, 2. So here 2 will come. Now what will be the value of fib 2? Again we need to calculate. Fib 2 will return you fib 1 plus fib 0. But why are we calculating it again? We have already calculated it once, okay, but we are not keeping track of that in recursion. So that's why we need to calculate it again, right? So there is a duplicate calculation, you can see. So so don't you think if I can create one array, and in that array for fib of 2 I store already the value 1, and if I check if the value of that seal is minus 1, it means it is not calculated yet, and if it is something which is other than minus 1, it means that I have already calculated it. I don't need to calculate once again. I'll just take the value from there and put it here, right? So this process is called memoization. Okay, you are storing the result which you have already calculated, so you don't need to calculate it once again in the morning in the future. So now fib 4 will return me 2 plus 1 3. What fib 3 will return you? Fib 3 will return 2. The 3 plus 2 is 5. So fib 5, the answer will be 5, correct? 0 1 2 3 4 5. So the answer will be 5, which is correct. Now if you see here, you can see from graph also, right? So for fib 5, see, for fib 5, you were calculating fib 4 and fib 3, right? For fib 4, you were calculating fib 3 and fib 2. For 3, again you are calculating fib 2 and fib 1. For fib 3, you were calculating fib 2, fib 1, right? And for this, fib 1 and fib 0. Similarly for this also, right? No, this one though will directly return you, and here also fib 1 and fib 0. So can you see how many times, if you take an example of fib 2, how many times you are calculating it? 1, 2, right? 3. And if I say fib 1 so you don't need to calculate. Fib 3, if I say 1, 2, right? So you can see that I'm calculating same thing again and again. And so the best thing is you just remember that, okay? If you see the time complexity of this recursion is 2 to the power n, correct? Where n is the number you need to find, and you can have 2 cases each time. That's right, 2 to the power n, which is exponential. So now to overcome this problem, to reduce the complexity, okay, you use the approach which is called tabulation. Okay, we have seen recursion, now we are seeing tabulation. So nothing, you will just create one table of fib, okay, where this one will be from 0 1, it is already base condition, from 2 3 4 5 n, okay, till n, and then which is started from 0 1, and 0 1 you already know the value 0 1, and initially the value will be -1, and once you calculate it, you will just replace that value here, and next time when again fib2 will come, you just get value from this array. So that is what we do in dynamic programming. Okay, so now let's see what we do in a tabulation method, okay, and what will be the complexity in a tabulation method. So let me remove this. Okay, so now here what I said, the same thing I'm doing here. See, if n is less than equal to 1, then you return n, the same base condition. Otherwise, you will create a DP of size n plus 1. Why n plus 1? Because our indexing is starting from 0. Okay, 0, 1, 2, 3, 4, and 5, and we were returning the fifth element. Correct? That's why n plus 1. And then you know the base condition DP of 0 and DP of 1 will be 0 and 1. Correct? This one will be 0 and 1. And then you will run one for loop from I equal to 2 to I is less than equal to n. Okay, because you need 5. So less than equal to n, and then here instead of calling recursion function recursively, this function again, you will just get that value from this DP array. Let's say I have created one DP array here. Okay, so this is my DP array, let's say, and here I need to find the value of fib, let's say fib 5. Okay, so what I will do here, I'll create one DP, and then DP0 and DP1 will be 0, 1, and then I'll run one for loop from 2 to 5. Okay, and then DP of 5 is equal to DP of 4 plus DP of 3. Okay, and then sorry, my bad, DP of not 5, we are starting from 2, right? So DP of 2 is equal to DP of 1 and DP of 0. So what is 1 and 0? 1 is 1 and 0 is 0. So DP of 2 will be 1, right? Similarly, you will run DP when I equal I plus plus for 3 you will run. Okay, so you will run for DP of 2 plus DP of 1 for DP of 3, right? So you already have value for DP of 2, which is 1, right? Plus, and this one is also 1, so this one will become 2, so you'll put it here 2, and then DP of 4 you will run for 3, then DP of 5 you will run 5, and at the end you will return DP of n. So this one, the 5 will be your answer. So here you can see that we are doing bottom-up approach, right? In recursion we were using top to bottom approach. Okay, first you were going inside the recursion, and then you're coming to 0 and 1, and then from there you will returning the answer. So you were going top to bottom, but here you know that we have already started from I equal to 2. Okay, not I equal to 5, from I equal to 2 you have started. So you were using 0 and 1's value, and then you were using that. So that is how you use for the memoization, okay, tabular form of bottom up. The first video is little bit longer, but from next onward we will be completing it with a good speed. Okay, now if so, here the time complexity will be order n, okay, and space complexity will be order n. But here I wanted to reduce this space complexity. So how you can do that? See, if you wanted to space optimization of the DP, then you know you don't need to contain the complete array. Okay, you just consider last 2 values, that's it. We are not using the earlier values, right? So what you need to do, you take 2 variables, which is previous 2 and previous 1. Okay, now instead of and then initially previous 2 will be 0 and previous 1 will be 1. Okay, now when you run for I equal to 2, when you run it, so you will do summation of this. Okay, so you will have a new value. So this new value now will become previous 1, and this one will become previous 2, right? And then you will, for I equal to 3, you will again find one new value, so that one will become previous 1, and this one will become previous 2. So that is how you just use 2 variables, okay, and you're changing the value. So let's say if this is called current, so current equal to previous one, and previous one equal to previous one, and at the end you will return previous one, the last one, this one, right? So, and here the space complexity will be order 1, time complexity will be order n. So that's it. Thank you.